So plug gauge. So plug gauge is used to inspect holes. And suppose if you look at the diagram, go gauge and no go gauge. So go gauge, suppose if I am inspecting a hole of 50 mm, so go gauge is it's less than 50, 49.9. So it enters into the hole. And no go gauge, it's 50.2. It doesn't enter into the hole. So the component is accepted. Similarly, ring gauges, gap gauges and snap gauges are used to inspect shafts. Suppose if you look at this one diagram, it is snap gauge, where you can insert the shaft in this and check whether it is go gauge or it's going or not going. So here also go gauge and no go gauge values will be there. So for ring gauges and gap gauges and snap gauges, these are all look similar, but there is slight design changes are there to get more accuracy. So snap gauges are more accurate compared to the gap gauges and ring gauges. Linear measurement, next one. Linear measurement is steel rule, generally scale, which is also called in technical we call it as steel rule. It is used for linear measurement to measure the length or width or height of the component. So even calipers, vernier calipers, screw gauge are used to measure the linear measurement. Surface plate and slip gauges also used for linear measurement. Next, angular measurement. So angular, we use protractor in diagrams. So protractor is one of the angular measurement which we use in our daily applications, and in experimental applications for accuracy purpose, sine bar, angle decker, autocollimator, clinometer are used for angular measurement. Next one is flatness measurement. Optical flat and optical interferometer are used for flatness measurement. And comparators, what is the purpose of comparators? So comparators are used to compare the dimension of a component which we manufactured with the standard dimension. So if our dimension, the component dimension meets with the standard dimension, then the component is accepted. Otherwise, if the defect deviation is more from the standard dimension, then depending upon the accuracy we need to maintain, we will decide whether we need to accept it or reject it. Next is taper measurement. So taper is the angle which is shown in the diagram theta. So rollers and cylinders and depth gauge are used to measure taper. So if there is any inclination on the cylindrical shape component, we need to measure the taper. So next is sine bar. Sine bar is used for small angular measurements and as well as error in angular measurement. So why we need sine bar is more important? So that's we will discuss with small example. Sine bar, it is a surface. These are slip gauges. This is the sine bar. L is the distance between the centers of the rollers, and H is the height of the slip gauges. L equal to distance between distance between rollers, and L is distance between roller centers. And H is height of slip gauges. So from the, if you want to measure the angle here, sin theta equal to, the theta is this angle, sin theta equal to H by L, that's why it is called sin bar. So if you want to measure the error in angular measurement, error equal to d theta equal to tan theta into dh by h minus dl by l. So it's, the principle is based on the trigonometry in sin bar. So because if sin, we are using sin formula, that's why it is called sin bar, to measure the angle of a angle for angular measurement. Next topic is Abbe's principle. What is Abbe's principle? So here Abbe's principle explains that axis of measuring equipment and axis of component must be parallel or perpendicular. Axis of measuring equipment and axis of component must be parallel or perpendicular. Parallel or perpendicular to each other. This is about Abbe's principle. Suppose if you are measuring a straight, one rod length, then you have to keep the scale parallel to the axis of the component. That is, both are parallel. Suppose if you are using vernier calipers and you are measuring the diameter of a component, then the axis is perpendicular to the component. Chalk diameter, suppose you are measuring chalk diameter, for example I will draw. Vernier calipers I am using. Here I kept chalk. Sorry. So if you want to measure the chalk piece diameter, this is axis of chalk, right? And vernier calipers axis is, so both axes are perpendicular. So if you measure length, turn the chalk, then the both axes are parallel. Here one example of Abbe's principle.